Welcome back to Awesome Metrics. I'm Pratik Kamasani, and in this module, we're going to look into the how to implement the ingestion layer based on the architecture that we created. The fun thing is I recorded this entire video and then I went back to edit it and then realized there was no sound. So I am re-recording the video again, but the problem is I already created the notebooks and everything that's needed for the ingestion layer. So what I'm going to do is I'm just going to go and talk through what I have done. You're probably not going to see the step-by-step process that I kind of tried doing it for the previous recording, but you'll still be able to see how we are building this ingestion layer. So based on the architecture diagram, what I've done is I've created 3 folders, which are one for each transformation layer, one for ingestion, validation, and the curated layer. What I also did is I actually prefixed them with the number 1, 2, 3. So it's easy for me so that they're always in that order when I sort it on the name, and it's easy for me to go and just click on the folders that I'm interested in. There is a environment that was created when we were exploring our data sources, and so does the notebook one that we created in the very first video. So I'm going to go to my ingestion Awesome metrics. What I've done here is I began with creating a lake house. So I am following in naming conventions here. What I'm doing is, because this is a lake house, so I prefixed that with LH, and then I'm working with the raw data in here, so I added raw, and my project is Awesome metrics, so basically that's kind of where the naming convention is coming from. I haven't updated the description yet. I will update the description a bit later. And what else I have done here is I have the 3 notebooks which I am using for the ingestion. But if you look at the naming conventions that's happening there, again, I'm following the same naming conventions where I'm using the NB for the notebook. I'm ingesting the data, so that's why I'm doing the ingestion, and it kind of talks about where the data is coming from. So in this case, I'm getting the country and city data, Europe weather data, and the world data. Here I used raw instead of doing ing like ingestion, because there I'm storing the raw data. So for that reason, I kind of went for a raw naming convention, and then wherever I'm ingesting the data, I went for ing naming convention. It makes sense for me, but depending upon what works in your development, you could go for that one. I wrote a blog post about this naming conventions. Please go and check that out. So first thing first is the country and the city data. So what's happening over here is in my lake house. If I go back to my lake house and go to files, all the data that's available on the GitHub, where we have the world cities data. This is a CSV that I downloaded from the world cities, and here I have the information about the cities and the Latin lang and the things around it. However, there are some cities that's been missing in that data, so that's why I went and I downloaded the other cities as well. I downloaded all of them into CSV, and then I am going to convert those CSVs into Delta tables. Well, not really converting, importing those CSVs into Delta table. So that's kind of what's happening in this code block. So I created 5 data frames. Each data frame is basically just reading each CSV file, and I'm combining that data frame into one data frame, and here I'm just showing how the data is looking, and then I'm putting that data into a Delta table into the lake house that's been attached to this notebook. So a format that I'm kind of follow for in all the notebooks is, first I give a variable and I provide the table name. This is the table name, and then I'm using that table name over here, save as a table. So it's kind of helps me to just copy and paste the code between the notebooks so that I know that I just have to replace the table name. And when I'm writing, in this case, I'm overwriting because this is kind of a static data. I'm not really updating this notebooks, so that's why I'm just keeping the overwrite, and the rest of the things are like, it's a delta format and I'm merging the schema and things like that. So in what I have here is it's giving me the cities in the world. But however, what I'm interested in is I don't want all the cities. I'm more interested in the cities only in the Europe. So for that case, what I went and got the continent and the cities within the continent. So this is again, very static data. There might be better ways of getting this information, but this is what I could find and in the short amount of time. But this is kind of what happens with any open data projects that we work with. When you're working with open data projects and when we are looking for various data sources, sometimes you just have to go and get whatever it is and transform it in a way so that it works for you. That's pretty much what I'm doing here. So what I'm doing here is I'm combining, again, for each continent, I'm going and I'm getting the cities for each of those continents, and I'm putting that data into a table called raw_countries. So if I look at my lakehouse, so this is where the raw_countries, and then I also have world cities. Those are the two tables that we just inserted. And this is kind of how the data looks in the raw_countries. It's nothing but a continent and the countries under that continent. So which helps me to go and combine those two tables and get the data that would be useful for my API calls. What I'm interested in is I want to be able to filter continent. I want lat and lang for each of the cities. And that's kind of what's happening over here. I've written a little SQL query to get the column names that I wanted. And then finally what I'm doing is I'm creating one more delta table which has this joined information from those two tables. And at the end, this is how the data looks like. So that's pretty much what's happening in this notebook. And one other notebook that I also have, which is the world data. This is where I am calling the World Bank API and getting the data for each of the countries. Again, this also gives me lat and lang, but at country level. So this is a very simple script that's happening here. So what's happening here is I'm calling the API, and the API has multiple pages. So if I go back here, you could see there is this here. I'm sure I am looking at page 1, but there are 6 pages in this API call. So for that reason, what I'm doing is, in this case, so basically I'm calling the number of pages, and then based on the number of maximum pages that's available, I'm looping in here to just basically go to next page, and get all the data and then keep that into a table called raw World Bank countries. So if we go back to my lakehouse and look at the data, so this is the kind of information I have in here. The thing I quite like about the World Bank countries is where I have this income level. So this could help me to see if whether impacts on the income level on things like, may be able to do some more reporting analysis. But I do feel like most of the things that I want is available in the raw global cities information, because I have the continent and I also have lat and lang for each of the cities, and I also have the population information, so that instead of me going and calling API for every possible city, what I wanted to do is I want to filter on the population. So I could use the population, do the ranking on the population, and get only top 1 city or top 2, 3 cities, and get the data for only those cities. I went for top 2 cities, which I'm going to show in the next notebook. So this is my Europe weather data. There's actually a lot happening in this one. So the first thing is I'm importing all the libraries that I need. I am using the environment that I've created previously, because I installed the libraries that's needed to call the OpenMetro API. And there are some other libraries that's kind of related to the operations that I'm doing in this notebook. So first, I am calling that global cities and I'm putting the data into a data frame. Then I'm filtering on the continent name, and my continent name I've given as Europe. So I have only Europe continent in this data frame. And then I'm converting the population to integer, doing the sorting, and then doing ranking. And finally, at this step, I am basically choosing only where the rank is equal to or less than 2, which means I have the subset of countries where, subset of cities where they based on the population, which helps me to not abuse the free API that we have and get only the data for fewer cities, because the use case here is not about creating an extraordinary analysis on weather data, with more of exploring the fabric, but in a very real life scenarios. So I think for that use case, this amount of data is much more than enough. So I'm going to come back to this function in a sec. This code that I have in this code block is what I basically did is, if we go back to my main folder, and this is the notebook I have. So I basically just kind of copied the code from this and pasted into the other notebook, which I know that this code is working. However, there are a few changes that we had to do. The thing is the parameters. When it comes to parameters, there are a few things. First, lat and long, because we want to make them dynamic so that we provide lat and long for the cities that we are interested in. And the next thing is start date and end date. We also want to make start date and end date dynamic, so that we are not every time you're not going and bringing all the data. In fact, you actually just go and get the latest data. So this is kind of what we do with most of the projects that we work on as well, is like we tend to do incremental loading than just going and doing the insert every single time, which is not a best practice. So that's kind of what I wanted to do over here as well. So if we go back to notebook, okay, there are a few things that's happening in this code. First thing is lat and long. So what's happening here is that if you look at this loop, this is where I am looping in Europe countries data frame. I'm getting lat and long for each of the city, and I'm assigning that lat and long as a parameter when I'm calling API. So this is kind of what's happening over here. So that's with the lat and long. And the next thing that's happening is the start date and end date. For the start date, I am giving a default start date. So in this case, my default start date is beginning of the year. And then what I'm doing is over here, I'm checking if the table already exists. So when I'm importing the data, my code logic is I want to go call the API, get the city for a particular city I've given. I want to go and get the data and save the data into a delta table for that city. So I'm not appending all the data into one table. Instead, I'm creating separate delta table for each city. So in this case, I am going and checking, is there a table exists for this table, for this city? If the table exists, can you check what is the maximum date in that table? I get to see when was the last data that's been inserted into that table. If there is a maximum date, it uses the maximum date. If not, it would use the default start date. And this bit is useful, especially like, if you have a table, but if there is no data in it, then it's always going and using the default start date. Or if the table doesn't exist at all, again, it uses the default start date. And then for the end date, it's using the current date time. So whenever we execute this notebook, it uses that date as the end date. And I'm providing these two as parameters in my API calls over here. Before I provide those variables, I'm actually converting them into a string format so that my API works, because it expects a string format. And I'm also using the sleep command so that I'm not abusing the free API. So every time the API calls, it waits 30 seconds and then calls the API and brings the data back. And finally, it keeps the data into Lakehouse. The moment I paused it, because I don't want to run it for all the cities, but when I execute it, this is kind of how the data looks like. Is like, if I look at this one block, this is one block of the code where it's going and it's calling the country and then the city in that country. So this is the country and the city name, and this is the table name that gets created, and then it's checking if the table exists or not. The table doesn't exist, so it's assigning the default start date as the start date and the end date as the whenever I executed this notebook, and then it's waiting for 30 seconds here for the API call to be done. I think there's one bit I forgot to mention is about the table name. So when it comes to the table name, each city may have spaces, or it may have some special characters and things like that. For that, I'm using a function called defined a function, remove all characters. Basically what it does is it takes the input string and it looks for the pattern, and if there are any characters that I mentioned over here, then it basically replaces them with blank string. It's not even blank, there is just it removes them, and that is what I use for my table names. I go back to my Lakehouse and view the data for one of the table that's been created. As you could see, there are quite a few blanks, but however, there is a lot of data for temperature when there's not that much snowfall. There is a bit of rain for this city. So I'm going to go and execute the code for all the cities and probably change the default date to like a 5 years or 10 years or something like that, and load all that data, which helps me to have the data for my semantic model. But however, if I go back to my notebooks and look at the Europe weather data again, when I see this output, when I execute this in this view, it does help me to see what's happening. Like, it's going through each of the city and it's bringing the data, when was the start date, when was the end date, and things like that. This is where it's useful when you're in developer mode and you're monitoring your execution. But however, it's not very useful once your solution is in production and you want to understand how the solution has been working, if there are any issues with your everyday schedules and things like that. That's when logging helps massively. And also, even just over here as well, tidying up and adding the good error handling and the monitoring also helps to capture that extra information, like if when things goes wrong. So that is what we're going to cover in our next video, where I will be showing you how to create the logging in this solution. So if I went a bit too fast and it's too hard to catch up, all these notebooks would be available. And I've also written a blog which kind of talks about what's been happening in this one. So please refer the blog post if it's too fast, and check out the notebooks that have been shared. But I'll see you in the next video.